next speaker holds a degree in business administration from RMIT and is a certified digital transformation management professional and IoT specialist. So to talk about considerations in deploying intelligent edge devices, please welcome Mr. Colin Ko.
Okay, thanks. Good afternoon, everyone. Thanks the previous speaker talk about a lot of these AI technologies and also a lot of challenges that facing the industry. In fact, 25 years ago, when I was working with some of my industry partners, we introduced the fuzzy logic. So I look back, fuzzy logic actually is part of the subset of AI, and fuzzy logic has been so pervasive in all the consumer products. So that was my first encounter in terms of the AI in applications to the industry. Okay. I'm Colin Ko, a senior manager from this LKH Pressicon. LKH Pressicon is part of the listed company in Singapore. And what we do is that for the last 30 years, we have been serving industry, mainly in the manufacturing, as well as the infrastructure and the institutions to provide automations and subsystems to support their automations journey. So this is what we supply to the industry. Basically, is a lot of these sensors, even robotics, vision system, safety, controller, things like that. So in fact, edge computing, if you look back, is not new. It depends on how intelligent is the edge processors. So for instance, as you know that in the factory, we use this so-called the programmable logic controller. So this is one of the first edge computing that we'll be using in the factory floor since the 1970s. Why is not called the so-called the intelligence in a way that because during the time I think AI wasn't that pervasive, and a lot of technology don't allow the AI to be used in some of these applications. But some of these applications that use in factory are very critical, right? You imagine that you have a controller that control the production floor. So what happens if the controller is not working, or if any machine is down, they actually affect the productions. And you know that I give an example, for instance, any machines downtimes in the semiconductor wafer fab, which we have been selling a lot of our product and services to them. Any downtime actually can cost them millions of dollars. So it's very critical. So this is one of the application I find the edge computing can be helped in terms of solve some of these issues, which is still currently very pervasive in our industry. So I've been sharing a lot of my sharing in terms of the IoT, Industry 4.0, right? And recently, I co-authored a book called Industry 4.0, Navigating the Manufacturing in ASEAN. The reason is we find that the Industry 4.0 and some of these smart factory, smart manufacturing concepts are not well received by a lot of these manufacturers, especially the SME and especially the mid-sized company. They intend to go into the Industry 4.0, but they still find that how to start, where to start, you know, and in a way that how to develop a roadmap. So I think this is one of the objectives that we write this book, try to share what we know. So I think previous speaker has been talking about the centralization and decentralization. I think this is something not new. So if you can recall that in 1950s, right, you had a mainframe. This is very centralized computing. But when it comes to 70s, in fact, during that time I was working in the workforce, we used to have a mini computers, right? So this is again distributed control computers. And 1990, you see a lot of corporate data center. In fact, now a lot of corporates still have their own data center. Basically, I think it's the deployment of the client server technologies. Early 2000, this is where we see the cloud architecture start to become very popular, right? And so I think you know that in mid 2010, the edge computing and the smartphone has been used everywhere. So there's no hard rule to say that which computing is better. In fact, the centralized and the decentralized approach actually is complement each other, and that this model will be still continuous, right? The next maybe 20-30 years. So as you know that the prediction is the edge computing will generate so much data, right? And one of the way is to how to ensure that all this data are not pushed to the cloud. So imagine that if you look at, for instance, Google have implemented edge computing, right, at their server side, and that actually saved them to avoid building another 15 big data centers. So I think this is one of the benefits, the edge computing, that actually will help both at the data center as well as the edge devices. For instance, the server, the gateway, or even the micro data center. Micro data center will be very pervasive in the future. For instance, we expect all the factory, they will not want to push all the data to the cloud. But what happened to the data? They still need to store them, still need to process them. So as you know that a lot of companies already invested developing so-called these micro data centers. So we see a lot of these micro data center will be on the shop floor everywhere. So the consideration of deploying edge devices, this I think some of the speakers have mentioned, but I want to look at some of the on-site issues. So bandwidth is one issue, right? So as you know that the bandwidth is still very expensive, right? So if you want to push all the data using the bandwidth, it's not possible. So the bandwidth is an issue we need to consider. Connectivity is another one, right? So connectivity in the shop floor, I think we still use a lot of cabling, right? Hard cable to connect. But we see also the trend that people are still using the wireless on the shop floor. One particular issue that facing a lot of these industrial application actually is the environment. So for instance, you have if you need to deploy an edge devices in those areas which is high vibration, high temperature, or even high EMC. So EMC is the electromagnetic compatibility issues, especially in the high-tech industry or even heavy industry. The electromagnetic noise is very high. So if you try to deploy some of these edge devices without considering this, I think a lot of these devices will not work. And on that basis, I think our company also provide this EMC audit and also some services to help the manufacturing company to overcome this issue. Latency, I think everybody talking about it, latency, and I will talk about more detail in terms of latency later. How about the perishable data, right? As you know, that I think in the manufacturing floor, we are running at a very high speed. And all this data, sometimes it's just, we don't collect all these data. But some of these data can be very useful, right? From the edge computing or even the AI processing point of view. So we have to consider what are these data that you need to collect. You don't collect all, but which are data you need to identify in order to make sense out of it. Security is another issue, right? I think you know that security is the biggest roadblock in terms of stopping a lot of manufacturing company to invest in a lot of this IoT and also a lot of this AI and data processing technologies. The other one, I think some previous speakers have talked about the data privacy. So you know that some of this IoT stuff that you deploy in certain setting, all this data, some of this data that is required by end user that have to comply to certain regulation. For instance, the EU, the GDPR, I think some of the speakers have spoken about. The other one is more critical, I think, in terms of in our area, in terms of manufacturing, is the intellectual properties. Some of these data are actually proprietary data, and some of these design data are also very highly, in a way that a lot of value in it. So if the edge computing or the edge devices are not able to protect some of this data from leaking out to the factory, this is where also a lot of factories are very reluctant to use some of these latest technologies. So these are the considerations I find that in our experience by talking to our customer, these are a few so-called the hurdle that we need to cross. Just now I mentioned about the times and the mission critical aspect. So I want to relay back to manufacturing factories, right? So manufacturing factory, they have different processes and different response they need to take. I give examples. Let's say an equipment failure, as I mentioned, let's say with a fab. When you have a machine that fails, they actually can cost millions of dollars to the manufacturing plant. So how can you detect the machine before it fails, right? So you need to really have a very high processing power and also very accurate predictions in terms of when the machine will fail. In fact, now a lot of the factory, they're taking a different approach to solve these problems. So first, the worst thing is they just react to failures, right? Then better arrangement is they do a preventive maintenance. That's to say that they will do a maintenance, they say once a week or once a month or once a year, regardless whether the machine fail or not, right? But again, this is also very expensive. We are trying to envision that the edge computing and some of this AI should be able to help in both this mission critical as well as some of this data can be used to do predictions. So once you're able to do better predictions, you are able to manage the downtimes, right? So the time and value relationships in terms of selecting the right types of edge computing is become very critical. So I think it depends on the individual plant owner. They really need to identify what kind of the edge computing and what kind of edge devices or even the AI applications they need to put. So these are the considerations the engineers, the plant managers, they need to take a deeper understanding in terms of their processes in the plant. So these are the things that the advantage for business and also some of the questions they need to ask. I think we cannot just buy technologies. At the end of the day, you must understand as engineers or as a plant owner or even as a so-called the business owner, you have to understand that when you deploy this technology, what does it mean in terms of your business impact, right? Does it help in terms of improving your productivity, improve your efficiency, or improve your quality, or even security aspects? So you have to really considering all this before you deploy the technologies. Because sometimes you are so excited when a vendor comes to your door and show you all kind of shining technology, and you think that you should buy, right? But before you buy, you really need to think very hard. Does it help you, right? And the other area is also, you know, that because of the so many of these smart devices all over the place, what is your device deployment policies? So as you know that 10 or 20 years ago, there's a policy called bring your own device. But as you know that now, do you even allow your worker to bring their own cloud? Something you have to think about it, right? And in order to provide a very robust data collection, data analysis, or even all this AI benefit, you really must ensure that you have a robust digital infrastructures, right? Other than your physical infrastructure. So I think these are consideration. We find that a lot of our customer, they tell us these are the concerns. So we really need to understand, we need to empathize them before we propose any solution to them. So these are the, I think the previous speaker has spoken about the edge computing use cases. So for me, I'm more familiar in terms of the industrial IoT. So for instance, the manufacturing production line, and as I mentioned, the predictive maintenance. How can we improve from doing the different level, or we should upgrade our level of in terms of the maintenance regimes. So I think AI and edge computing come in handy. And you know that a lot of these manufacturing, they start to deploy a lot of these autonomous mobile robots. So in the past, I think a lot of these robots are not intelligent. When I say not intelligent, because they are unable to navigate in the plant. But now I think with the AI and also some of these so-called the vision systems, all these advanced technology and the sensors, I think all the sensor has been around for many, many years, but the cost is very expensive. But now, as you know that since the inventions of the iPhone, all the components, the cost of components have been dropping more than 100 to 1,000 times. So this is where I think a lot of these intelligent sensors have become very, very, very cheap and can be used back to those areas that which is previously not possible. So some of the use cases, for instance, the mining industry, I think has been a very famous application, right? So now you're able to even navigate your mining machines, but without putting a human inside the machines, and you're still able to do your mining activities using all the latest sensing and all the latest technologies, the edge computing and all this. And automotive, of course, I think previous speaker are talking about the autonomous vehicles, right? Remote healthcare. So consideration is also a data privacy. Smart agriculture. So somebody call it precision farming, right? So this is one of the application that can be used in those countries which have a lot of agriculture industry. So drone delivery is one of the applications that people are talking about. So I think in Australia, right, people are already using the drone to deliver some of the product to the end user. Okay, this is one of the graphic that we have developed based on a book. So if you look at, this is a very typical manufacturing setting. And you know that Industry 4.0 is talking about cyber physical. That's to say that you want to virtualize your factories, and not only virtualize, your factory have to be very smart. So in the past, it's very difficult to achieve all this. But based on all the technologies that we have seen, and some of this development R&D project has been going on, and some of the previous speakers have talked about those technologies, become affordable, and some of these become more reliable. So I think this is one of the areas that in a manufacturing setting, we find a lot of opportunities. You can use edge computing. Of course, you have to consider those areas that I have spoken about. So you have to do some pilot POC, and you have to look at what kind of POC you want to do. So as I say, that as a business setting, you really need to look at those so-called quick win projects, or even the low-hanging fruit to start off. But before you do any of this project, you have to make sure that whatever you invest in the POC, you are able to scale up. If not, then it becomes a single POC, and sometimes can be very expensive. So many people talking about the up and coming the connectivity, which is a 5G. So as you know, Singapore already rolled out the 5G. So the first phase is rolling out the immersive broadband, right? So this is basically allow maybe some of these video streamings and some kind of maybe AR, VR to be used. 5G, in terms of the timeline, 5G will only become very robust and very matured and pervasive maybe 5 to 7 years from now. But nevertheless, I think we should not wait that. So we should maybe work with some of these innovators. So I think Singapore, I know that some of this IHL already have some of this 5G lab that allow you to test some of these rollout phase by phase. So I think 5G, in fact, is one of the very critical general purpose technologies in the coming year. The reason is a lot of the activity, a lot of processes, and a lot of the technologies or even the automations we cannot fulfill in the last 30 years is because of some of these factors: connectivity, the bandwidth, latencies, and also the capacity. So I give example. Let's say the current LTE base stations. At any time, you only can log in maybe 100,000 of these IoT sensors, which is not possible for you to do so-called the smart city applications. The 5G within the same base station, you can log in maybe 1 million IoT network, or so-called IoT node. So only this thing will allow a lot of these applications. So if you see a lot of this POC and some of this application is now currently doing, they cannot scale up because either the bandwidth, latency, or the capacity is just unable to do it based on the current 4G spectrum. So I think this is one of the areas that a lot of people are putting a lot of hope, right? And in fact, 5G will transform a lot of business model, right? For instance, a lot of the product will become services, and a lot of this digital economy will become more pervasive because of 5G, and also one of the unique point of a 5G is also the securities, right? So for instance, if you look at the 5G network in terms of IoT, the built-in security is the phase 2 or phase 3 is going to be 266 bits, right? So this is a very highly secure IoT framework, which is not any of this current IoT security able to fulfill because of the processing speed, and also because of the some of these the security technology have not catch up. So as I say that industry 4.0, right? And this is something that is a journey that we need to walk through. In fact, we have been working with a lot of our customers to ensure that we are able to provide the right technology, and we also help them to develop the POC and even some of the technology roadmap with them. So this is what we have done in Singapore, right? So the enabler for the edge computing, I think some of the previous speakers have spoken about. So these are the few things. So as I mentioned, for instance, not only the software, the hardware, the infrastructure in terms of the connectivities, the 5G, things like that. So as you know, the 5G has certain very special features. For instance, the network slicings, right? Which is in the past, a lot of technology cannot achieve that, or it's very expensive. For instance, in the past, people used to maybe just buy a lease line. But now I think the 5G wireless network allow you to achieve almost the same characteristic of performance of a lease line. So I think this is very exciting. The other area I want to mention is about the micro data centers. What happens if all the manufacturing floor, they start to deploy all these edge computing right into their production systems? And as you know that not all of this data they can push to the cloud. But what to do with all this data? Because some of this data can be very valuable, right? Can be turned into a lot of intelligence. So we actually foresee a lot of this manufacturing floor, they will start to so-called install this micro data center. And this so-called industrial grade micro data centers is very small size, but it have all the features of a traditional data center. So we also see a lot of this opportunity when people start to install some of these micro data center. In fact, the smart city or even the smart nations, if you can see some in future, you can see the roadside will be a lot of this micro data center there. Basically, the thing they will do the local processing and send only the necessary data back to the cloud, right? So these are the enabler for the edge computing now and maybe for foreseeable futures, maybe the next 5 to 10 years. So as you know that a lot of AI, people talking about the platform, AI is a platform, and even the explainable AI. This will take another couple of years to become mature, right? So I would say that the timeline is we have to prepare for it. But I think edge computing and some of these technology are already available. In fact, we are seeing a lot of our vendors start to offering this to our clients, right? So it's an exciting time. So this is my closing. So thank you very much. So I'd like to thank APARA to giving us these opportunities to share. Thank you. Take over, please.
Thank you so much, Colin. Thank you for your sharing.